Hi, in this tutorial we're just going to go over functional groups. We'll see lots of molecules and chemists will say, oh, you changed this functional group into this functional group. So basically I just wanted to introduce you to functional groups as a topic. So if I just bring in a molecule here, for example, and a lot of you might not know what this molecule is, but you've certainly heard of it. This is aspirin. Okay, so this is aspirin. This is the non-steroidal anti-inflammatory drug that we take, certainly when as adults, to relieve symptoms of pain and things like that. Now if I take another molecule, I've not mentioned what functional groups are yet, but I take this other molecule here. Again, you'll be familiar with this molecule, and in the UK it's got its name is paracetamol. So we've got paracetamol and we've got aspirin. Now these are completely different drugs. They work in similar ways on cyclooxygenase pathways, but the mode of action is different. And that's because they interact with the cells in the body and the proteins and things in the body due to these functional groups. And it's the functional groups and the structure, the 3D structure, that actually makes them work as a drug. So if we look, if I just get a different colour pen, at the functional groups, first of all I need to point out what a functional group is. So a functional group is part of a molecule which has a specific name. So you can talk to chemists about parts of molecules. So if we talk about aspirin, it has functional groups here. This bit here is called a carboxylate. So it's in this case it's a carboxylic acid, and in this bit here looks very similar to that one there, apart from instead of having a hydrogen it's actually got a CH3 group. So when that line comes out there, that actually means there's a CH3 group on CH3 there. And actually I will just expand that little drawing bit there beyond. Okay, so we've got a CH3 group there. So that is what's called an ester. So this is a carboxylic acid. Carboxylic acid. And you might have come across these words before, and this is called an ester. And don't worry too much about my handwriting. I'll put the words up on the website. And this group here, this is a benzene ring, but it's called an aryl group or phenyl group. Okay, so and that's called aryl or phenyl. Phenyl just means it's got one benzene ring. Okay, so aryl just means aromatic. So if we take those principles, we've got a carboxylic acid there, we've got an ester there, we've got phenyl, and where they're stuck around the molecule just gives rise to certain properties of the molecule. So in this case aspirin. So if that ester group was in this position, not this position, it wouldn't work like aspirin does, but it would have the same functional groups. Now if we look at paracetamol, this group here is called an OH. We call that an alcohol group. Alcohol. And I'm sure most of you have heard of alcohol. Again, we've got this phenyl group. So these are just parts that we can name as building blocks, really. And this part here is called an amide. And an amide is made up of a carbonyl, that's another functional group, and an amine stuck together to make an amide. So just as a recap, I'll draw this in blue. A carboxylic acid functional group looks like this. An ester looks like this. And I'm going to put R, and that's another thing we use. R means, put equal sign there, alkyl. Okay, so an alkyl group is basically something like CH2, CH2, CH3, and this bit's stuck onto something else. Okay, so it's stuck onto whatever here. That's an alkyl group. This can sometimes be used to explain other types of hydrocarbons, so you might have some complicated structure like this, say CH3, and this bit here is stuck onto the carboxylic acid bit, and you'll probably call this R, even though it's got alkene groups in there. That's because basically, as chemists, rather than draw out the whole molecule, we'll just talk about what's going on at a certain part, so we'll just abbreviate the rest of the molecule to an R group. But what we'll do, we'll put the complicated structure up. For example, if I drag in morphine here, so this is morphine. Let me just get my brush. So this is morphine, and some of you might have heard of morphine. So morphine's a naturally occurring drug. We can talk about this, but then we might want to be interested in reacting this bit here. So if we just react the alcohol bit there, and we want to talk about that, we might just go HOR, and that, say it reacts with I don't know, something like this. I'll put an X there, and I'll explain what X is in a minute. And it becomes CH3, it becomes an ether. That's another functional group, an ether there. So if we want to talk about just all that, rather than drawing the whole molecule, you can see how it took me seconds to write that. And to be honest, I do have another structure, which is actually what that is. This is another molecule, very similar to morphine, but it's got a CH3 group on there. Now, I'm not saying that's how you make it, but this is called codeine, and you might have heard of codeine, because again, codeine and paracetamol and aspirin are all painkillers. Morphine's actually a really good painkiller, but codeine's not as addictive as morphine. So this is codeine, and I promise I'll type these up. Okay, so it's getting the screen's getting a little bit messy here, but I'll just move some of these structures out of the way. I'll keep that because I might use it later, and I'll keep codeine, and I'll just delete these bits here. Okay, so basically a functional group just makes it easier for chemists to talk about structures. So if we take paracetamol, the functional groups that are present would be alcohol, aryl or phenyl, it's up to you. On this case, if it's just one benzene ring, we'd tend to call it phenyl. And then at the end there, we've got the amide. Other functional groups that I've not mentioned are, if I just get my black pen here. So we've got the R group is used to explain what a large alkane, or even a CH, it can be CH3, it can be ethyl, propyl, butyl, so it can be CH3, CH2, CH3, and so on and so on and so on. So that's that. We tend to write AR, and that can mean, I've seen it used for one benzene ring, but typically AR is used to explain more complicated aromatic systems, such as the naphthol type of species, or I've even seen it used as for indoles and things like that, where people are just writing it in shorthand, and you might want to put that stuck onto somewhere there, and you might just call that AR. So it's just anything that's slightly aromatic, you'll type AR, even like pyridine or something like that. You know, you might want to just call that AR. Strictly speaking, it's not quite the same, but again, it's used for shorthand. It's used to speed things up when you're talking to people, or you're giving a tutorial like this, for example. So that's AR. That's aromatic. That's one of them. I'll put a list of all these up. So common ones are ketones. So a ketone would have two R groups on the side. aldehydes. So that's a ketone, aldehyde. Now a aldehyde is very similar to a ketone, apart from one of the R groups is a hydrogen. Now that's very important, because when you building molecules up, you can react. You can oxidize this up and react it in a different way to how you would play around with ketones, for example. So that's ketone and aldehyde, two very similar structures, and you can see the relationship here between aldehydes, ketones, esters. So that's an ester, and the carboxylic acid. I wrote them up there, but they're based on this carbonyl functionality here. So C double bond O, and then whatever's coming off the side there. So that's a carbonyl. That's a carbonyl group. I mentioned the alcohol group, which is just a carbon single bond oxygen. You also get nitrogen, hydrogen structures, and these are called amines. And depending on the number of alkyl groups or whatever substituents are on there, so if a nitrogen stuck onto the end of a molecule, and this is an R group, then that's called a primary amine. So it's primary amine. If it's got more than one, and I'll put a prime there. I'm going to explain what that means in a minute. That's called a secondary amine. Okay. And I won't draw it, the next one. If it was completely full with alkyl groups and lost all its hydrogens, that would be called a tertiary. So I'll write the word, but tertiary amine. Okay, so that's with all of them there. You notice I put that little prime. I did mention I'd come back to that. Sometimes when you want a different R group or a different alkyl group, but you want to tell the listener, whoever you're talking to, it's actually not the same one. So it could, this one could be a CH3 and this one could be CH2. Then you might want to just put a prime or number them up, just to indicate that they are different. Because if you put R there and R there, and they could easily be two methyl groups, and it wouldn't be very clear. So that's a basic introduction. I'm just going to put up a few structures and let you have a quick look at some of the functional groups in some common molecules. So again, we've got another anti-inflammatory drug here. This is ibuprofen, and we've got this drug here, which is nicotine, and of course we've got morphine from before, and I'll put codeine up there. Okay, and I'll just get rid of these. Oops. Okay, so just very quickly now, just as a recap really, we've got an alkyl group stuck on there of ibuprofen. This squiggly line means basically that methyl group, because that should have a methyl there. This is, again, if you look at the other tutorials on drawing organic compounds, sometimes these, they've missed it out there. I'm not a big fan of that, to be honest, because it's not very clear sometimes whether somebody's just forgot to put hydrogen on, or it's just that we happen to know that nicotine has this structure. So sometimes so you can see the CH3 has been added to that one. You could very easily have left it like a line like they did with nicotine, but I think if it's a terminal CH3, it's probably best just to put CH3 there. Then the reader or listener does know that it's not an error in the structure. Something like this, you can't really make an error there because it's continuing on. So back to the structure. So we've got an alkyl group here, we've got an aryl group there, phenyl group, and we've got carboxylic acid. Okay, so a structure not too dissimilar to aspirin. There's the main theme is there's an aromatic there, and there's some kind of carboxylate things there as well, and so you can see how they're kind of related, these compounds. Morphine, on the other hand, has got quite a lot of functional groups. We've got the alcohol, we've got a lot of alkenes here, you've got the tertiary amine there if you look, so you've got CH3 and you've got some alkyl group going off that way and another alkyl group going off that way. You've got this double bond here, that's an olefinic group. That might be an old word now, it's just something I keep using. And then you've got your aromatic group there, and here you've got an ether, so carbon oxygen carbon bond is called an ether, and you might have heard of ether as in diethyl ether, which was used in the olden days as an anaesthetic, and it leads to lots of complications if you use it, but it's mainly used as a solvent these days, but they're moving away from that as well. So again, if you look at codeine, very similar structure to morphine, we have now an ether, slightly different. That's the only difference between morphine and codeine, is this CH3 group here. We look at the structure, again, apart from that ether group, it's all very similar. So we've got the alcohol there, ether, and of course the aromatic group there. So this was basically just an introduction to functional groups, but throughout the rest of the tutorials I will go on about functional groups, and hopefully you'll learn the nomenclature and the naming systems that we use for functional groups during the organic reaction mechanisms tutorials. So I hope you enjoyed this. Please have a look at the other tutorials as well. So there's an introduction to drawing organic structures, which I do recommend you look at. Okay.